Today we're going to talk about to find the surface area and volume of composite 3D shapes. So last time we talked about finding the surface area and volume of just a 3D shape, but now what we're doing is we're taking two or more shapes and we're stacking them on top of each other or putting them next to each other. We want to find the surface area of that whole image. Before we talk about what lateral area is, let's look at this picture here. Now, the top shape here is a pyramid because there's one base. And the bottom shape here is a rectangular prism because my bases are all rectangles, so it's a rectangular prism. So notice if I were to find the surface area of this whole pyramid and this whole base and this whole rectangular prism, that would be completely redundant because I do not need to find the area up here. I am taking this, it's like I took a pyramid and a prism and I glued them together, and all I want to do is I want to wrap the outside of my box. So think about this like being like a giant princess tower. In your princess tower, you're not wrapping the roof to the base of the roof to the base of your tower, you're wrapping everything around it. So that's where lateral area comes into play. Surface area with these types of problems is a little more challenging than volume. Volume, it's pretty easy. You fill up the volume of this shape, you find the volume of this shape, you add them together. But when you're, again, finding the surface area, you have to ask yourself, okay, well, what don't I need? In this pyramid, I don't need to wrap this base. And in this rectangular prism, I don't need to wrap that base. Okay? So if we were to quickly talk about what it means to be lateral area, remember lateral area is the area of a shape without the base. It is the area without the base. So this really comes in handy when I don't want to have to find the area of the base. I just want to find the area of the sides, the lateral faces. So why is it important? It helps me find the area when I don't need the base. Okay, so not all formulas have lateral area. If you take a look at your formula sheet, if I look at a pyramid, my pyramid, I do have the formula for lateral area. So I'm going to find the formula of this. I'm going to find the lateral area here. So the formula is 1/2 LP. All right, so 1/2 L is my slant height of my pyramid, which is 12. P is the perimeter of my base. So if this down here is 10, I know this down here is 10. And if this is 10, I know that up there is 10. So 10 plus 10 plus 10 plus 10 is 40. So my lateral area of my pyramid is 1/2 times 12 times 40, which in this case is going to be 240. I'm just going to lightly circle that so my brain remembers where it is. So now, if I were to find the lateral area of a prism, the problem with a prism is a prism has two bases. It has this base up here, and it has this base down here. So I don't want to get rid of both bases. I only want to get rid of one base. I only want to get rid of this top base up here. And if you look on your formula sheet for rectangular prism, you don't even have a lateral area formula. So I'm going to find the surface area, and then I'm going to talk about what I need to subtract. So my formula is 2LW plus 2LH plus 2WH. Plug all that fun stuff in. So my length is 10, my width is 10, my length is 10, my height is 32. My width is 10, my height is 32. So if I type all of that into my calculator, 2 times 10 plus 10, that's 200. And then 2 times 10 plus 32, and 2 times 10 plus 32. I'm going to have to type that into the calculator because my answer key does not look like it has it. So, bear with me here just a second. I have 200 plus 2 times 10 times 32 plus 2 times 10 times 32. I get 1480. 1,480. But that's the whole surface area. I do not want the area of this rectangle up here. So I now want to subtract the area of that, which is a rectangle. Base times width is 100. So I have 1380 as my surface area. Now I lightly circle it. Now, the whole surface area of that whole Princess Tower is 240 plus 1380, and 240 plus 1380 ends up being 1,620 feet squared. So now you might be wondering, instead of subtracting 100, I could actually technically omit this 2. Because this is saying 2 times these bases and 2 times those bases and 2 times the front base and the back base. So you could technically omit that 2 and make it 1, and that's also going to get you 1380. For whatever reason, that's harder for my brain to interpret. So I think about if I don't have the lateral area formula, I'm going to find the surface area and I'm then going to subtract. I'm going to take out what I don't need. Okay? So now I'm going to erase my images here. So now we can find the volume. Surface area is much harder than volume. So volume, all I do is find the volume of the pyramid, find the volume of the rectangular prism, and I'm done. So volume of the pyramid, volume formula is 1/3 capital B H. So 1/3, I knew this was 10 and this was 10, so I knew my area of my base is 100. But now I have to find my height. So I'm going to have to do some scratch work, so I'll do that in green. That's X. So that's 5. So I have to do the Pythagorean theorem. 5 squared plus X squared equals 12 squared. So I get, for X, I believe it's 10.9, but again, I can't read my answer key, so let's check this out. So I would do 144 minus 25, and then I take the square root of that number. Yep, 10.9. So this is X is 10.9, so times 10.9. So my volume of my pyramid is 1/3 times 100 times 10.9. And my answer key, man, is really slacking on me here today. 1/3 times 100 times 10.9. 363.3. Lightly circle so I don't lose it. So now I want to find the volume of my rectangular prism. Length times width times height. So 10 times 10 times 32. So that's 3,200 is the volume of my rectangular prism. So the volume of this whole composite figure is 363.3 plus 3,200. And you get 3,563.3 feet cubed. Okay, so again, I'm going to erase just so I have enough space on this next problem. But the nice thing with this video is if I'm erasing too fast, you can very nicely pause it and rewind. So I'm just going to scroll this way so we have ample space. All right. Now, this one, I have 3 images. I have a cone, I have a cylinder, I have a cone. So I'm going to find, and I do it in colors, surface area I always do first. It's the most obnoxious. I'm going to do them in different colors. Surface area of this cone. So now, let's talk about, do I want to do surface area or do I want to do lateral area? Well, do I need to wrap this base? No, I don't need to wrap that base. So I'm just going to do the lateral area. So lateral area of a cone is pi RL. Remember, it's extremely crucial you write the formula down, because if you choose on a test to not write the formula down and then you get the answer wrong, I can't see what you're doing wrong. So I always say my general rule of thumb is you get a point for writing the correct formula, you get a point for plugging in the numbers correctly, and then you get a point for your correct answer. So pi, my radius. So my radius of this has to be the same as my radius over there. So my radius is 2, because over here is 2. And my slant height is 3. So I'm going to leave this in terms of pi, because that makes it a heck of a lot easier. So 6 pi. I'm not going to find the lateral area or the surface area of my cylinder. Well, do I need my base? With the cylinder, how many bases do you have? You usually have 2 bases. I don't need either of my bases because, again, I'm wrapping this as a whole, so I don't need to wrap those bases. So, yep, lateral area is going to work perfectly. So the lateral area formula is 2 pi RH for a cylinder. So 2 pi, my radius is 2 and my height is 3. So 2 times 2 times 3 is 12 pi. Lightly circle so I remember where it is. Last one, I'm going to find the lateral area of my cone because, again, I don't need to wrap my base. So I already have that formula, but I'm still going to write it down for good organization. My radius is 2, and here my slant height is 4. So that's 8 pi. So that means my surface area of this whole shape is 6 pi plus 12 pi plus 8 pi, and that would be 26 pi meters squared. Now, if I didn't want to put it in terms of pi, I could then type in 26 pi into Desmos, or I could do 26 times 3.14. But using pi is just a slightly more accurate. All right, I'm going to erase so we can see it. You fortunately don't have to write as big as I do. And let's talk about volume. I just have to find the volume of 3 problems. Volume here, volume here, volume here. So, if we take a look-see, the volume of a cone, this one first, is 1/3 pi r squared h. So I don't know what h is, so I'm going to have to find h. So it's going to have to do the Pythagorean theorem. So x squared plus 3 squared equals, x squared plus 2 squared equals 3 squared. So I get x squared equals 5 because 9 minus 4 is 5. And the square root of 5 is 2.2. So 1/3 and 2.2. So now I'm going to type all of that into my calculator here. 1/3. You know what? Well, you can leave it in terms of pi again. Make it easier. You don't have to type it in the Desmos. Well, why not? Let's just type it in as a y, because since I'm already typing, I get 9.2 for my volume. All right, while I'm doing the volume, it's a little harder because I have to find the height. I'm going to go ahead and find the height here too. That's 2 and that's 4 and that's x. So I have x squared plus 2 squared equals 4 squared. So 16 minus 4 is 12. So I get 3.5 for x. So volume is 1/3 pi. My radius is 2. My height is 3.5. So 1/3 pi times 4 times 3.5. I get 14.7. All right, so now all I have left to do is to find the volume of the cylinder. So the volume of my cylinder formula is pi r squared h. Don't think I have these memorized. I'm just referencing a formula sheet. Pi, my radius is 2, and nicely my height is 3. So I have 2 times 2 times 3, so I have 12 pi, which is 37.7. So, to find the volume of the entire shape, I now have to add up those 3 numbers. So it's nice because everything is circled. It's easy for my brain to reference it. I get 61.6 meters cubed because it's volume. Okay? So we're going to skip number 3, but I want you to try number 4 on your own. When you finish number 4, you can either pause or you can unpause this video and fast forward to get the answers, check your answers to make sure they're right. And then if they're not right, you can obviously rewind so you can see where you made your mistakes and what I did to get my answers. So I'm going to do surface area first because it's harder, so I like to get it out of the way. So with my cone, I definitely want to do the lateral area because I don't need the area of my base. So lateral area is pi RL. My radius is 4, and my slant height is 7. Now I can do this in terms of pi in my head, so I'm going to leave it in terms of pi. It will be very specific on what it asks you for what it wants if it was a test question. So now if I want to find the lateral area of my cylinder, it's going to take away both of these bases. So instead, I'm just going to find the surface area, and then I'm going to subtract the area of that base. So surface area is 2 pi r squared plus 2 pi rh. So 2 pi, my radius is 4, plus 2 pi, my radius is 4, my height is 12. So I get 128 pi. But now I need to subtract the area of this base. Well, what shape is that base? Well, that base is a circle, so I have to find the area of that circle. So that's pi r squared. So that's going to be pi times 4 squared, so that's just going to be 16 pi. So I want to subtract 16 pi. So my surface area of my cylinder is 112 pi. So that means my surface area of my whole image is 140 pi inches squared. So now I'm going to find volume, so I'm going to erase all of this so I have some space. So I'm going to find the volume of a cone first, which means I'm going to have to find this height here. So the volume of my cone is 1/3 pi r squared h. I know my radius is 4, but I don't know my height. So I have to come over here and do some scratch work. X squared plus 4 squared equals 7 squared. So 49 minus 16. Well, it'd be helpful if I was typing it in the right blank. And then square root of 33. I get 5.7. So now I can type all of that fun stuff in my calculator. I can do 1/3 times pi times 4 squared times 5.7. I'm going to end up with 95.5. Lightly circle so I know where it is. I'm now going to find the volume of my cylinder, which is pi r squared h. My radius is 4. My height is 12. So in my calculator, I would type pi times 4 squared times 12, and I get 605.2. So to find the volume of the whole image, I would add 95.5 and 605.5.2, and I get 698.7 inches cubed. Now, some of you might be wondering why surface area I left in terms of pi and volume I didn't leave it in terms of pi. Personal preference, but one of the main reasons was this piece up here. I don't like leaving something in terms of pi if I'm going to have a decimal. So like I think it's silly to write like 3.3 pi. I would rather just, if I'm going to have decimals, I would rather just give all the decimals. So that's why I typed, because I knew 1/3 was going to be 0.3. And if I typed all of that into my calculator here, and I'll do it here just to make sure, sometimes it balances out nicely where you don't get a decimal, but I know you're not. If I can type again into the calculator. Yeah, I end up with 30.4, so I don't want to write 30.4 pi, so that's why my general rule of thumb is if you have decimals, don't leave it in terms of pi, just go ahead and type pi in the calculator to get your answer. So you're going to work on the problems on the back, and then if you have questions, make sure you come and you ask.